Hello my dear friend, I am Prabhas Barik and I welcome to my channel for Abhas Me. So do not waste of time, let's go to the exact video. Okay, nice. Indigestion, sore stomach and heartburn, etc. are the main problem that occur in our daily life. It can be cured by magnesium hydroxide, or it's called as milk of magnesia. Chemical formula is MgOH2. Okay, serve as both antacid and laxative. Okay, milk of magnesia is a common laxative and antacid medication that has been used since generations. Okay, milk of magnesia is also cure from these problems. Okay, there is examples where come in our chemical life. There is ENO. Okay, we have to drink it through water. Now I come to hair shampoo. Okay, it is a lubricant. It is a example of shampoo that is Head and Shoulder. Okay, its chemical formula is sodium laureth sulfate. Okay, you can see the structure of the sodium laureth sulfate in the figure. Okay, there is sodium laureth sulfate, an accepted concentration of sodium lauryl ether sulfate is an anionic detergent and surfactant found in many products. Okay, it is used as what? Surfactant. So do not waste of time. We have to go to the main video. Okay, nice. Thank you. Now the chapter is enzyme. It is also called as biological catalyst. It was given by Kuhne, Kuhne, in 1878. Okay, it can be divided into two parts. Inactive protein is called apoenzyme and another is active protein. Okay, and the active protein including cofactor is called holoenzyme. Okay, the cofactor is also again divided into two parts, organic molecule and another is metal ion. The organic molecule part is called also called as coenzyme. Okay, then I come to nature of enzyme. Okay, at first composition. Okay, enzymes show usual proportion of carbon, hydrogen, nitrogen and sulfur as in protein. Okay, such enzyme on hydrolysis produce amino acid. Next I come to amphoteric nature. Okay, amphoteric nature, like protein and enzyme behaves amphoteric. Okay, in the electric field they are behave as what? Amphoteric, and also they are having isoelectric point. Okay, next I will come to denaturation. Okay, enzyme get denatured protein and loses its enzyme activity. Okay, next formation of antibody. Many purified enzyme when injected in the body produce specific antibody. Okay, next I come to characteristics of enzyme. Okay, at first catalytic efficiency. Okay, what is catalytic efficiency? Enzymes are very efficient catalyst. The speed of the reaction is 10 million times comparison to uncatalyzed reaction. Okay, so very small amount of enzyme needed to catalyze the reaction. And next we come to specificity. What is specificity? These are highly specific in their action. Who? Enzymes. Okay, due to their shape, size, as well as size of the substrate. For example, invertage act as sucrose to glucose plus fructose. You can also know about it. Okay, then we come to effect of temperature. Okay, what is effect of temperature? Enzymes are most effective near body temperature. Above this temperature, they loses their activity. Okay, they do not require its maximum above than 35 degrees centigrade, and do not they require its low temperature. Okay, because below and above of 35 degrees centigrade, they decreases their activity or loses their activity. Okay, next I come to effect of pH. What is effect of pH? The effect of pH on the rate of an enzyme catalyzed reaction passes through maximum at optimum pH. Okay, at higher or lower pH than 8, the enzyme become less active, because pH 8 is its maximum optimum value. Okay, next I come to presence of electrolyte and UV ray. The enzyme loses their activity in presence of electrolyte when exposed to UV radiation. What? UV radiation. Okay, because the enzyme gets denatured in presence of electrolyte or UV ray. Next we will come to enzyme inhibition. Okay, what is enzyme inhibition? Enzymes are very sensitive to catalytic poison. Okay, enzymes are very sensitive one who get poison and how to cure it. Okay, at first enzyme is very sensitive to catalytic poison. Example, H2S, HCN, CS2, etc. Okay, they lose their activity in presence of this substance because they have a tendency to absorb on the surface of the enzyme strongly. Next we will come to effect of metal ion. Okay, what is effect of metal ion? There are certain enzymes which require non-proteinous substance for their activity. Okay, these can be metal ion like sodium, copper, iron, zinc, magnesium, or small organic molecule like coenzyme. Okay, a large number of molecules like vitamins, okay, such as thiamine, riboflavin, niacin, etc. So in certain cases the enzyme activity can be reduced or inhibited by the presence of certain compound like enzyme inhibitors. Okay, you have to make its summary. Okay, what are the content? Okay, there is the nature of enzyme. There are 4 content. In characters of enzyme, there are 7 content. Okay, you have to make content and you have to remember it, for which you can write in your paper. Okay. Next I come to Fischer lock and key model. Okay, it is specific for enzyme. Okay, its main postulate is specific enzyme has specific substrate. Okay, specific enzyme has specific substrate. You have to remember it first. Okay, then their mechanism is represented by me. Okay, this is my handwriting. Okay, in step 1, enzyme and substrate will add and give intermediate complex, enzyme substrate intermediate complex. Okay, then in step 2, this complex enzyme substrate intermediate complex will give enzyme product complex. Okay, in step 3, enzyme product complex will give enzyme plus product. Okay, then I will show you the picture. You can see in the picture. Okay, that at first what enzyme and substrate at the active site they will add what they form enzyme active enzyme substrate complex. Okay, fits like key into a lock. That's why it is called Fischer lock theory, no? Okay, and it become what product and okay there is also enzyme product will start and become product and unchanged enzyme. This is unchanged enzyme and okay this is unchanged enzyme and these are the product. Okay, so next I will come to enzyme kinetics. Okay, Michael Menten equation is a most important to remember you. Okay, it was given by Michael Menten in 1913. Okay, I will tell the content. Okay, you have to write the note and I will tell this is a two-step reaction. Okay, first is enzyme plus substrate. ES complex will form and K1 K2 are the what rate constant. Okay, and second enzyme substrate complex give product plus enzyme. K3 is the third rate constant. Okay, rate you can also form rate. Okay, d constant of S by dt is equal to plus dp by dt equal to K3 ES. Okay, you can also form it. Okay, according to steady state we can also steady state apply in this equation. Okay, dES by dt is equal to K1 ES minus K2 ES minus K3 ES. Okay, now enzyme conservation equation will apply. What is E0 is equal to E concentration and ES where E0 is the total energy concentration and E is the free enzyme concentration and ES is the bound or reacted enzyme concentration. Okay, next putting this value E value in equation 2. Okay, then dES by dt will form and it becomes 0 as given in the equation 2. Okay, so at last you can balance it. Okay, next in the above equation ES will get common and ES will become as this like in the structure. Okay, then put the value of ES in equation 1. What is it equation 1? Equation 1 is K3 ES. Okay, put in equation 1. Then R3 is equal to K3 E0 S by K1 S plus K2 K3. Then R will be K3 is equal to K3 into E0 S plus Km. Here Km is equal Michaelis Menten constant. Okay, and the equation is called Michaelis Menten equation. Okay, where Km is equal to K2 plus K3 by K1. Okay, if you take the case there will be appear something and I will take two cases at higher concentration of substrate. Okay, and at lower concentration of substrate. Okay, next at last there will be a graph will come. Okay, you can also see it also represent two characters. One is zero order reaction and there is this part is first order reaction and it become zero order reaction. Okay, next I come to inhibitor. What is the inhibitor? I will discuss about it. Okay, at first what competitive inhibitors. Okay, at first competitive inhibitors. Okay, it occur at the active site and the structure of the inhibitor resembles the substrate, thus it may combine to form EI or enzyme inhibitor complex. Next, compete with substrate. Okay, the inhibitor compete with the substrate to combine with enzyme. Okay, and the degree of inhibition depend upon the relative concentration of the substrate and inhibitor. Okay, next is E means enzyme bind with substrate or at inhibitor form ES enzyme substrate complex or enzyme inhibitor complex, but not ESI. Okay, but not ESI. So competitive inhibitor reduces the rate of reaction by reducing the proportion of enzyme molecule bound to separate substrate. Okay, there is a example of also I will discuss about it. Sulfur drug act as inhibitor to combine bacterial enzyme at the active site, block tolic acid synthesis. Okay, next it also help in treating patients who have ingested methanol. Methanol means alcohol. Okay, in non-competitive inhibition there is no competition occur between substrate and inhibitor. Okay, and EI and ESI formation because inhibitor bind with enzyme at a place other than active site. So substrate and inhibitor combine at different site. So EI and ESI formation occur. Both complex break down to produce reaction product. Here the inhibitor and substrate bind to the enzyme simultaneously. Okay, there is an example. What is urease? Okay, urease enzyme. What will its action? ESH plus Ag plus is raised to ESHG plus H plus, because metal like Ag plus H2 plus are high affinity to SH group. So Pb poisoning can be removed or cured by this method because these metals are high affinity to SH group. SH group will add to ES. Okay, you can also see in the reaction. Okay, if there is some poison intake person, then it can be cured by this process. Then uncompetitive inhibition. Okay, it is also known as anti-competitive inhibition. Inhibitor bind to ES complex, not to free enzyme. ESI cannot form product. Okay, next, if substrate concentration is high, then uncompetitive inhibition work. Okay, next it is allosteric inhibition. It is also known as non-competitive inhibition. It is also formed as a negative modulation, and a regulatory molecule bind to an enzyme in a spot different from the another molecule, which causes a conformational change in the active site for the second molecule, preventing binding. Okay.